In this lecture, we're going to revisit some of the skills we initially acquired in our first lecture on scripting stored procedures. And this really isn't very different in the sense that we're going to have the same elements, but we're going to add some elaborations that I think are worthwhile to explore in an instructional video. One of them is we're going to add the current date, which of course we're just going to use a function to generate that. And we're going to do some handling of an empty string. And so that is important. Remember, empty string as distinct from null. Null is no value. Empty string is specifically the value containing the empty string, or quote, quote. So we know it's a string type. It just has specifically no values set in it, similar to a null, but slightly distinct. And then the other thing is error handling. So let's see how we can introduce some error handling and alerting in both the message that's generated, which is going to be useful. There's two kinds of messages. There's the messages that we want a user to have, and there are the messages we want the maintenance programmer to have so that they can correct when errors are occurring. They can find out what the cause of it is. So one is generic and pretty friendly. The other one is very highly technical and provides important detail. Sometimes we'll provide one, sometimes the other, sometimes neither. It depends on our program requirements, the specifications for the system that we're building. So we want to throw an exception, and we want to handle that exception appropriately. So in this case, let's read through and see what kind of error handling we're having to do. So let's read the whole problem statement. We're going to write a script that creates and calls a stored procedure. We're going to name that stored procedure SP insert product that inserts a row into the products table. Okay, similar to what we did in our very first exercise. This stored procedure should accept one parameter for each of these columns: category ID, product code, product name, list price, and discount percent. This stored procedure should set the description column to an empty string, and it should set the date added column to the current date. Now, error handling. If the value for the list price column is a negative number, the stored procedure should raise an error that indicates that this column doesn't accept negative numbers. Similarly, the procedure should raise an error if the value for the discount percent column is a negative number. So we're trapping against negative numbers. There's other kinds of range checks and trapping we could do. And essentially any of the business rules that would apply can be crafted and added here. And if we're going to handle those on the fly, linking it to a meaningful error message so that the user either knows how to correct what they're doing, or if it's a system error or error that isn't otherwise handled, shouldn't occur. Obviously, the user can enter whatever they wish, so that is going to happen, and then you want to correct them. Maybe at the application level, that is handled before it even gets to the database layer, and that's fine. But otherwise, you want the database to give a meaningful error back. And failing that, we want to have a detailed error response so that the folks doing maintenance programming can go, okay, why is this error that should never happen occur? So even things that shouldn't happen but could are properly trapped by the logic, and we have good quality code. Okay, and we need to code at least 2 exec statements that test this procedure once we get it all up and running. Okay, that's all fine. Let's have at it, because there's quite a bit to do here. So let's start with the pro formas. We're going to use my guitar shop, and we're going to create this new stored procedure. But if it exists before we create it, we have to drop it. So that's just housekeeping. Okay. And then let's see what we need to do next as far as what does the header look like for this stored procedure. So let's look at the first half. So we're going to create the procedure. Here's the procedure name. and we've enumerated all the parameters. It's going to get at category ID as int, product code as varchar 10, product name as varchar 255, list price as money, discount percent as money. And again, where do I get these? Generally speaking, if these are field values that we're going to be working with, you should go look at the column definition for that field in the table. And as a rule of thumb, the data type and size should match the way that that is declared. If there's a business reason why it needs to be different, usually it would be shorter, you would be aware of what that is in your specifications, and you would code to that specification accordingly. So we're going to declare that as something. And let's go ahead and let me get rid of some of these blank lines here, because we don't need to take up that much screen real estate. It's just a little clearer to read it initially. So we're going to create this as what? So what is our code? So the first thing I'd like to do is validate these parameters. Let's look at our error handling before we get started on doing the work. So to validate the parameters, here's how we want to approach it. We're going to say, hey, if the list price is less than 0, remember that's the test for a negative number, it's less than 0, then we're going to generate an error or generate an error message. How do you do that? The command for that is called throw. And we're also going to give it an error number. Now, as we create our system, there is a range of numbers, error numbers that belong to system generated errors. And then there is a range of numbers above that that you can use as user defined messages. And in our system, we would keep track, whoever our maintenance programmer is, or our programmer librarian who helps check in all the code into a repository, they would be helping us to keep track as to how we, in the specification, assign the blocks of messages. And a lot of times, a range of numbers will have to do with the same kinds of errors. Errors having to do with I/O might be a certain range. Errors having to do with missing data might have a different range. There can be a whole schema and a taxonomy to that. That's beyond the scope of our discussion, but I mention it so that you are aware of it. So we're going to throw this error that we're going to call 5001, and we should never duplicate that unless it's exactly the same error, right? So we can have meaningful, distinct error numbers and error codes. And this is going to be defined in our good book of error codes that we're going to create for the project. The list price must be a positive number, okay? So fine, that's the error message we're going to throw if we get a negative number for list price. And this one, and apparently the specifications, the designer in their wisdom has said, well, anything that is supposed to be a positive number that's not, we're going to call it 5001. So if we had decided we need, to be so down to the details that list price negative numbers are 5001, we could have made this one 5002, but we're going to call 5001. So we're deeming this the same error. Okay, so a nitpicky but important detail. Do you want this to be 5001 or 5002? Again, how detailed and meaningful do you want the error message to be? You can imagine if you had this for everything. Let's say you got 1,000 different inputs in the system that all can be rejected because they're a positive number. That you might just go ahead and say, just make them all 500001. It has to do with it shouldn't be negative, and it's not unique enough that it has to have its own error code number. So again, that's a design decision. This is pretty standard practice. It's the same class of error having to do with the same kind of problem that has the same sources. In this case, it's going to be user input. Could be potentially processing an input stream of data would throw the same kind of error, and we're going to be happy with it as 5001. All right, so now that we've got our error handling taken care of, let's get on with the actual insert logic of the stored procedure And I'm not going to belabor that because you know how to do inserts at this point, and we've also done stored procedures to insert data. So I'm just copying and pasting my solution here, and I'll add some commentary, and that is we're inserting into products, and then field, 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 field. There's our field list enumerated, and the values are going to be the parameter that was provided, the parameter that was provided, the parameter that was provided, parameter that was provided. Look at this one though. Here is tick mark, tick mark. What is that? There's not a space between them. See, as I move the cursor, that's just tick mark, tick mark. This is the empty string. You could do that by calling the function to generate an empty string, or just the string literal of the empty string. Typically, this is what I do. Some people like a different style, and they'll use a function or a constant name that refers to the string literal of the empty string. That's just a matter of style and the system you're working on. That's fine. And then provided parameter, and here we're calling get date to get the current date and timestamp as generated by the system, and we're going to put that in the date added, also commonly referred to in DBA practice as what we call the row effective date. Okay, so great. And we end that batch with a semicolon, and then we would fire that off to create all that with a go statement. And now we're ready to test it once the script has run successfully. So let's see if that does indeed run successfully. Fire it off. It says commands completed successfully. What are we trying to create here? SP insert product. If we come up here, refresh our database, take a look at the programmability and the stored procedures, we see that we now have SP insert product. So we have created it. Now we need to test and see if it works effectively. And once again, to document your work, you should probably be leaving this on the screen and getting your screenshot and copying the text of it into your documentation that you submit. I'm going to, for emphasis on the fact that it's already been created, I'm going to get rid of all that code, and we're going to go and test. So what would a test look like that should fail? We're going to test both affirmatively and negatively. Let's start by testing negatively. We want to test that failure is handled correctly. So we're going to try and insert this, and it should have a failure. Let's see if that is the case. Failure. And look, we got our message 50001, which is what we wanted to see, our error message, and our message text. The discount percent must be a positive number. Look at what we have here, -32, that's a negative number, and so that's not a legal value. Our negative test of that control is checking out. Let's do this again with a different test. Okay, let's test some success. So these should all be valid values, and execute it. It said it completed, and now we can go ahead and select that product back out and see that it is inserted correctly. I'm going to leave that exercise to you, the learner, but you will go ahead and select that out, and you'll see that it does indeed do that. And then let's go ahead and clean up. So that just inserted a product, and that's going to be some product number that's going to be greater than 10. So let's go ahead and just get rid of everything on that table that's greater than 10 for the product ID. Bam, those are gone. And just to see that we clean things up properly, let's do a select. And we're back to the clean original data set. All right, onward.